Hi, my name is Becky Magoon, and I am an electrical safety educator with your local electric cooperative. In just a few seconds, I'm going to share 3 ways to stay safe around electricity. You might be homeschooling right now. Maybe you're looking for some ideas on how to teach electricity. Maybe you're an educator and you're trying to share some good sources. I've included a link that has some great resources that are fun and educational. So use those to help enhance this homeschooling that you're doing. So what are those 3 ways to be safe around electricity? Well, the 3 I want to talk about today is first, you need to learn what electricity is and how it behaves. If you know that, then you don't have to memorize any rules about electrical safety. It'll just make perfect sense how you should behave around anything electrical. So what is electricity? Well, it's actually pretty simple. Everything in the universe is made out of atoms. Here's a model of a magnesium atom. You've studied atoms before, so you know they're made up of smaller particles, electrons, neutrons, and protons. The neutrons and the protons are in the center of the atom, in the nucleus, and they're pretty much glued there. They don't get out very often. Traveling around the protons are the electrons. The protons have a positive charge, and the electrons have a negative charge. And if you've used magnets before, you know that everything in nature that have opposites, like charges, they will attract each other. Opposites do attract. So electrons stay in an atom because they have an attraction to protons. The only thing is, you've probably played with magnets before. Oh, these are hard to pull apart because they're hematite, but if you pull them far enough apart, they lose that attraction. Electrons are like that. In atoms, if they get far enough away from protons, they lose their attraction and they leave the atom. Now, if you have a lot of electrons that leave at one time, you have lightning. It's pretty cool. It's a lot of energy, and we know it's super dangerous. So in the case of lightning, it's a really large expulsion of energy. It's tremendous heat and light, and we can't get lightning to do a lot of work for us because it's just too hard to harness and too unpredictable. But we have found that you can get electrons to orderly flow through some materials, and then we can get electrons to do work for us. This leads me to the second thing you need to know to be safe around electricity, and that is what conducts electricity. Some materials are made out of atoms that have such a tight attraction to each other, that the electrons don't really leave the atom. They'll make up materials that are called good insulators. Other atoms lose electrons easily. They make up materials that we call good conductors. First, let's talk about conductors. You probably know a couple of examples of materials that are really good at letting electricity flow through them. Probably the first thing that came to your mind were metals, and that's right. Lots of different metals will conduct electricity. And then something that's not a metal that's a good conductor, that's right, water. So it makes a lot of sense. If metal or water are electrified, then we don't want to come into contact with them. Now, on the flip side, you have materials that can protect us from electricity because they're made of atoms that don't lose their electrons. It's hard to get electricity to flow through these materials. I'm thinking of 3 that are really good at stopping electricity. You may be thinking of these too: rubber, plastic, glass, kind of a big family. It would include fiberglass, ceramic. Those we use every single day to keep us safe from electricity. So does this make sense? If you have a cord and the plastic is cracked or there's pieces missing, then you don't want to use that cord. Get rid of it and find a safe one. And for certain, we don't use anything electrical in water. Finally, I think that you really need to learn how electricity can hurt you. Now, we know that lightning, like the current electricity, has a lot of energy, and we know how dangerous lightning is, all that heat and light. So current electricity can be dangerous too. There is a lot of energy there. Let me use this to illustrate how electricity works. This is called a Sci-Fi tube. This has everything in it that it takes to get electricity to do work for us. There's a small power source inside. It's a battery, and connected to that battery are wires that go to LED lights. And then there's a metal band on each end. Both of these metal bands are connected to the power source, back to the battery. So if I hold on to this end and then I touch the other end, I can actually get the lights to light up and the buzzer to buzz. I can get electricity to do work. So how is this working? Well, I'm touching the power source, so the electricity, the energy, flows through me. And when I make the other connection, the lights can light up. Electrons are now flowing through them. Do you see how I'm making a circle here? Yeah, in electricity, we call that a circuit. So I am the circuit, and when I close the circuit, the lights will turn on, and when I open the circuit, the lights will turn off. Everything electrical works that way. It's that simple. Let's think for a second, though. When I touch this, electricity went through me. Because your body is made up of almost 70% water, we are really good conductors of electricity. Now, in this case, this is a very small battery. It doesn't have much electrical pressure, which we're using to get the electrons to flow. So you don't have much flow through you either. So you're not going to feel anything when this electricity goes through you. But we have to use a lot of electrical pressure, very high pressure on power lines, and we step it down to bring it into the house, but it's still a dangerous pressure when we bring it into your house. We don't want to come into contact with that electricity. We don't want to be part of those circuits. So it's really important to understand that we don't want to come into contact with electrical voltage, which is pressure, or the flow that it creates, which we measure in amps. I'm going to let you do some more study on your own about how electricity actually affects your body, but I think you'll find some really bad, ugly things can happen to you when you come into contact with electricity. Well, we covered all three. Those safety tips that I wanted you to know. First, you need to know what electricity is and how it behaves. You need to understand materials that are good conductors and also good insulators to keep us safe. And then finally, I'd like for you to understand what electricity does to you when you come into contact with it, when you become part of a circuit. I can't wait to get back into the classroom and study with middle schoolers and high schoolers to talk about electrical safety. Until then, don't forget the online resources, and have a great day.